Austin cinematographer Eric Graham utilizes math functions all the time in his work. Stick around after this help video to find out how.
One of the fundamental topics studied in algebra is the function. Remember that a function is an association between two sets. One set consists of the input values and is called the domain. Those are usually the x values. The other set consists of the output values and is called the range. These are usually the y values. What makes an association or relation a function is the fact that you can only have one output value for any given input value. In other words, one y value for any given x value. This might sound like some abstract mathematical concept, but it shows up in our everyday lives too. For example, the properly stocked and correctly functioning vending machine is a function. When you push the button for a root beer, you should get a root beer out. Press the button for an orange soda, you should get an orange soda. Now, if you press the button for a root beer and get both a root beer and an orange soda, awesome, free soda, but there's something fundamentally wrong with that machine. One input, two different outputs, not a function. Now let's look at some of the different ways a function can be represented mathematically. We'll start with graphs. In order for a graph to represent a function, it needs to pass the vertical line test. The vertical line test states that if a relation is a function, there can be no vertical lines drawn on the graph that will intersect the graph more than once. The graph on the right is not a function because we can draw a vertical line that will intersect the graph more than once. This doesn't happen to the graph on the left, so it passes the vertical line test and is a function. Now for equations, we have a couple of options. You can always graph the equation and use the vertical line test, or you can solve the equation for the dependent variable y and check it to see if you will get more than one output per input. In the equation on the right, if we solve for y, we see we get y equals plus or minus the square root of 4 minus x, which will give two y values for every x value, so it is not a function. The second yields y equals 4 minus x, which will give one y value for every x. So it is a function. Now let's look at what functions look like in tables. Which of the following tables represents a function? I'm going to be using mapping diagrams to check to see if there's an input or x value that maps or corresponds to more than one y value. Let's start with table 1. Notice that the x value of 2 maps to 3 different numbers. So table 1 does not represent a function. In table 2, all of the x values are unique, so each x value maps to a different y. This means that table 2 is a function, so we'll choose answer choice B.
Back when we would shoot film more often, it was critical to estimate the number of reels of film I would need to purchase for a project. The number of reels is a function of the number of minutes that get recorded, or, put another way, the amount of time in minutes is the input, and the number of film reels is the output. And because figuring this out is a mathematical function, I wrote an equation in my budget spreadsheet where x number of scenes means 3x rolls of film, or y equals 3x. That made it easier to estimate the budget for a movie, TV commercial, or music video. And even though we shoot digital more often these days, we use a function to determine the total number of terabytes to purchase for a project.